Algebra 1, we're at 9.5, learning what's probably the most famous equation from Algebra 1, which is a thing called Slope-Intercept Form of a linear equation. The equation for this is y equals mx plus b. I have no idea why they picked the letter m to represent the slope. Maybe seemed like S for slope would make sense to me, but maybe this has something to do with Greeks and history and foreign languages or something. I don't know. But the number next to the x in an equation is going to be the slope. The other number called b is a thing called the Y-intercept, which we've had other days. The Y-intercept is where you cross the y-axis. Somewhere straight above or straight under the origin is the Y-intercept. All of this, however, is contingent on the y has to be alone. If the y is not alone, that's not the right thing. To be in slope-intercept form, the y has to be alone, everything else out of there, and then the slope is going to always be the number next to the x. The intercept is just the other number. It'll be worth a reminder in a second. The slope is the change in y over the change in x, where this number used to send us up or down, and this number always sent us right. Positive slopes go up, negative slopes go down, everything goes right. We'll need that in a minute. But the first bit of homework, we'll just ask you, what is the slope and what is the y-intercept? For an equation like this, you can't answer that question yet because the y is not alone. The whole foundation to this lesson is the y has to be alone. So for us to get this y alone, we have to think about opposites. We always look to add or subtract first when we're doing opposites. Even though the order of operations doesn't like to add or subtract early, again, keyword, opposites. Everything is opposite, including the order. So if I want to get this y alone, I see some adding, I'm going to have to do some subtracting. I'd have to try to subtract 4x to get that so the y could be alone. If I subtract 4x, that's not like terms with this, so I'm just going to write 12 minus 4x. To get the y completely alone, I have to do another opposite. 3 is multiplying, so I'll have to divide by 3. 3 into 12 goes nicely. 3 into 4 doesn't go nicely, so we just write that as a fraction. Now that the y is alone, now we can answer their questions. The slope will always be the number with the x. When I wrote this, I wrote the xy thing first. Right now, the xy thing is second. That doesn't matter. The slope is the number with the x. The slope would be negative 4/3. The intercept is always just the other lonely number without a variable on it, which in this case is a 4. I don't know if our book in the back will do it this way, but sometimes they'll write the intercepts as ordered pairs, like 0, 4. Y-intercepts are always 0 something. So they might be okay with this in the back. Check it out. They might want to write it this way. Whatever they do, we'll just do the same. So here's another question, same game. They want to know the slope, they want to know the y-intercept. You can't answer that question until the y is alone. So to get the y alone, the negative 3 is going to have to sit there for a minute because that's a multiply divide to save for later. If we want to remove a positive 2x, removing a positive number can only be done by subtracting 2x. Just because this had a minus, it doesn't mean we're doing the opposite of that. Not yet. The negative and the 3 are stuck to y. To get rid of 2x, I'm going to have to subtract 2x. To get the y completely alone, I'll divide by negative 3. 15 dividing negative 3 is negative 5. Negative, because they're different signs. When I divide negative 2 by negative 3, that's a positive, because negative dividing negative is positive. And I'm going to have to go fraction. 2 dividing 3 is just a fraction with an x. And then they just want a list from us. What is the slope? The slope is the number next to the x. They want to know what is the intercept. The intercept is the other number, which is negative 5. And maybe they'd rather we write it like this. I'm not sure. The second group of the homework, and I'm peeking here at 394 just to make sure I'm on track. The first group of the homework, 1 to 8, you're good. Just write the slope, write the intercept. 9 to 16, they want you to kick that into reverse. They're going to tell you the slope, which they're going to do with the letter m, and they're going to tell you the y-intercept, which they're going to do with the letter B, and they just want you to write an equation. It's always going to be y equals, it's always going to have an x, and you'll always want to slot the slope next to the x. So with the slope of 2, just put a 2 there. With a y-intercept of 5, just throw a plus 5 on the end. If this was a minus 5, throw a minus 5 on the end. If this were a 0, then you could skip it. If the slope were a 0 and you put 0 next to x, 0 times anything is 0, and we could have omitted that, I guess. If the slope is 0, you could omit the x. But if the slope is any number other than 0, we'd want to do the slope next to the x, tack on the other number, then that'll roll you 9 to 16. 17 to 24, they want you to graph. Slope-Intercept Form is really good for graphing. Slope-Intercept Form is going to eliminate your need to make a table. If you can get the equation y equals, the table is no longer of any value to you. You could make a table if you really enjoy going x and y, and with y equals, picking some x's like 0, 3, and 6 to get your cancels going. If you're in love with that, you can keep doing that. But it's so much easier to use Slope-Intercept Form to graph by first spotting the intercept. Okay, with a positive 4, that's going to go up 4 and make a dot from the intercept. Then, here's the note I said would matter in a minute. This is the change in y to take us up, because it's positive. The bottom is the change in x, always taking us right. From the point I just established, I'm just going to go up 2 and right 3, and play connect the dots, hopefully with a ruler, and remember my arrowheads. That's the easiest way, I think, to graph. A question like this, you might be tempted to try to do intercepts, and if you liked intercepts, that's pretty good too, but you can't do the intercepts thing here because 3 won't go into 20, and that gets to be a mess. So what I would suggest is get the y alone. I see an add 3x, so the 20 is going to have to do the opposite and subtract 3x. To get the y completely alone, divide by 4 to make it 5 minus 3/4 x. And do what we did a second ago. Do the intercept first. That is up 5, make a dot. I knew that was the intercept because it's a lonely number without any variables. The slope is negative, so this top number would take us down, but the bottom number always takes you right from the location I established. Down 3, right 4, connect the dots, and on we go. This is already in slope-intercept form, so that's outstanding. I'll first do the intercept, down 2. Then second, I'll use the slope. I like to see a fraction for the slope. I can make anything a fraction anytime if I put it over 1. So the top will always take us up for positives, down if it were negative. Bottom always right. So up 5 and right 1 from here. So from that location, up 5, right 1, and then we'll connect the dot. This one, I would do intercepts. If it's in standard form, that meant x and y on the side, with a number out of the way. If 2 and 6 can go into 12, I would go back and do the intercepts because I don't think anything's as easy as that. If x is 0, cover up, and the y would be revealed as -2, which is down 2. If the y is 0, cover up. When we divide, the x is -6. So left 6, connect the dots, and we're good. If you wanted to demand to make a table, that always works, it's okay. If you wanted to demand to get this y equals and do them the way we did the others, that's fine too. You can mix and match now. If it just says graph, you make a call. You do whatever you like best. That'll take you from 17 to 24. It just says graph. So Intercepts if you like it, tables if you like it. If you can get it y equals and do the trick today, I think that's a good trick. The last thing they're going to ask you is yes or no, whether some lines are parallel. So here's the rule on parallel. They have to have the same slope, but they also have to have different intercepts. So here's a pair of lines that I made life easy for us. I already got them y equals, so that makes our life easier. You can see these have both slopes of 3, because that's with the x's, and they have different intercepts for the other numbers. A scheme like this, I would say, yes, those are parallel because they have the same slopes and they have different intercepts. On your homework, if they don't give it to you that simple, I want to see a little work where you get these things y equals. So if I ask you if these lines are parallel, there's no way to know until you try to get this y equals. So first, I'd leave the 3 there and get the x out. Since this is positive and adding, I would subtract the 2x away. When I get it completely y equals, I'm going to divide by 3. And when I divide 2 by 3, that is a fraction. When I go to operate on this, I'd leave the negative 6y alone. And I would get everything else out of there. A positive 4x would become a subtract. And add 12 would become a subtract. And then I'd have to do the opposite of the 6 is multiplying, I'd have to divide. So negative dividing negative is positive. 4 dividing 6 is a fraction that will reduce to 2/3. Negative dividing negative is positive. 12 dividing 6 is 2. And then I look around. Do these have the same slope? No, they do not. This is a negative slope. This is a positive slope. The rule is that slopes have to be the exact same. So that's a no. We like the intercepts to be different, which they were, but the slopes failed us, so that's a no. Homework we're working here is on page 394. So if you have any questions, send me an email. We'll set up a Zoom session or something. So, see you later.